diffraction of wave. Diffraction of wave. So what is diffraction of wave? Diffraction of wave is spreading of wave when a wave pass through a slit or round an obstacle. The property after the wave diffracted, right? So after diffraction, few things that you need to know, right? Which is frequency. Frequency. Refraction or diffraction. Frequency all remain the same. No change. So second one, we talk about the frequency. We talk about the speed. Speed of the wave. Speed remain the same. Right? Speed will change when it go to deep or shallow only. Right? So when diffraction, the speed will not change. So same as this, wavelength. We talk about wavelength. Wavelength, right? It is remain the same. Wavelength also the same. Wavelength, it will depend on depth. If the wave propagate to the deeper or shallow area, then the wavelength will change. But anyhow, if it diffract, means the depth it is still the same, so it will not change. So lastly, it is direction of propagation. Right? So it is change. Right? This one must change. Right? Direction of propagation will change. So now a few terms that we need to know first, all right, before we understand what is this obstacle mean, right? What is a slit, or we can call it a gap. We can call it as gap. Okay, now here, when I got an obstacle here, obstacle in BM, we call it as halangan, right? The wave go through, right? The wave here, it go to here. The wave hit here and then it reflect. Here it will reflect, but I am not interested. I am more interested on what is the wave, what is the shape of the wave. After this part pass through here, this part pass through here, what will happen? Right? I want to see what happened. But before I know what is this, so this is an obstacle. This obstacle, when the wave pass through the obstacle, round an obstacle, so what will the wave, the shape of the wave? So we are going to study. So this is called diffraction. And this part we are going to name it as A. The size of the obstacle, we name it as A. Right? The symbol for the obstacle, we name it as A. Right? Same as this, if the wave go through a slit or go through a gap. Right? So this is a small gap, or we call it a slit or gap. So when the wave passes through this gap, what will happen? Here it will reflect yes. Here it will reflect yes. But anyhow, when it goes through the small slit here, right? I want to see when the wave passes through here, what will happen? As same as this is we call it as A. This part, the size of the gap, we also name it as A. We also name it as A. Okay, so this is a slit or this is a gap. The gap. So when the wave pass through, what will happen? We are going to see. Now, what you need to know is the frequency remain, the speed remain, the wavelength remain. Just now, this one, what is this one called? This one we call it as wavelength, right? The wavelength. And this length, this line, we are going to call it as wavefront, as I told you before. Right? Wavefront. When the wavefront pass through here, so the wavelength, what will happen? We are going to study field if we talk about the gap first. If the A is bigger than lambda, all right? So in this case, we are going to study when the opening, right? When opening is big, we are going to see what will happen. When we draw, okay, see here. I'm going to use the gap first. When the A is bigger than lambda, means that this one is big. The size of the opening is big. The A, this is the A. The A is big right now, right? Where the lambda will be small. The lambda here is small. Right? Lambda here small. When the wavelength is small, it passes through. So I find it in the experiment. Right? In the experiment, it showed me this result. Right? It bent a little bit at the edge here. At the tepi here, it bent little. Right? At the here, edge here, it bent little. So when the wave pass through, the wave come to here. The wave come to here. The wave will spread. The wave will spread. Right? It only diffract a little bit at the edge here. Now, you see the direction at first, direction always 90 degrees, as I told you, direction always 90 degrees. When the direction comes to here, then it will show you a 90 degree. Here it is not so obvious, but it is bent a little bit. So you see it like bigger. Right? It is like bigger. So this is called diffraction. So I said when A is bigger than lambda, right? Diffraction is not obvious. When the A is bigger than lambda, diffraction is not obvious. Okay. When A is smaller than lambda, right, we are going to see what happened. When the opening is small, I want to see the slit is small. The A is small. This one is lambda. This one is A. I use the other color. This one is A. Compared to here, A is bigger than lambda. A is bigger than lambda. A is bigger than lambda. Now compared to here, this one. Right? A compared to lambda, right? Maybe I try to make it bigger. Lambda, the lambda is big. The A is small. The lambda is big. Lambda is big. A is small. So I find it after the experiment here, the wave is like bending a lot. It bent a lot. It bent a lot. Where the wave come into here, the wave come into here, it spread. It spread. You see, this one is 90 degree, this one is 90 degree, no problem. And after it spread, the wave direction is still 90 degree. Right? Now, what do you need to know is the wavelength, the wavelength after the diffraction. It is remain the same. The wavelength is remain the same. The wavelength not getting bigger. It is remain the same. Right? After the diffraction, the wavelength getting the same. Smaller than lambda. The diffraction is very obvious. What direction obvious means? It bend a lot. This one is called diffraction. The diffraction is very obvious. But here, the diffraction, it diffract not obvious. It only diffract a little bit at the edge here. What is diffraction of wave? Diffraction of wave is spreading of the wave. When the wave, spreading of the wave. When the wave go through a gap or slit means lubang lah, right? Small gap or small slit, right? It go or go through a round and obstacle. We are going to see round and obstacle one. When A is bigger than lambda, all right? So now I got one thing that block here. The A is big. This is an obstacle. This is the A. A is quite big. Now, my wave is coming from here. Right? The wave is coming from here. The wave is coming from here. When the wave come to here, it pass through the gap. It pass through the obstacle, not gap. Gap. This one is obstacle. Pass through the obstacle. I want to see in the experiment what will you see? Right? When the wave come to here, so it will bend a little bit at the edge here. When the wave pass through here, right? So when the wave go to here, when the wave come to here, now it is like coming this way, right? So this is called diffraction also. Sorry, when it pass through a gap, or it pass through an obstacle, and an obstacle, pass around an obstacle. You will see that this one is your lambda. Lambda before and after the diffraction, it is the same. Lambda before and after the diffraction, it is the same. After the diffraction, right? After the diffraction, the wavelength, it is the same, right? But you see the diffraction here, obvious or not obvious? Diffraction. Not obvious. Now we are going to see what if the A is small. This one is called A. A is bigger. Now this one A is bigger. You see here. This A is big. This A is bigger than lambda. Lambda is small. Lambda is small. A is big. A big, lambda small, not obvious. A big, lambda small, not obvious. Diffraction. But when A small, lambda is bigger, it is obvious. It is obvious. Okay. What if A smaller than lambda? Right? When the lambda is big, I find that this one, it bend a lot. It bend a lot right here. But after that, no more. Right? Here it bend a lot. After it go around the obstacle, so you see this part it bend a lot. Right? The wavelength here, right? Same. The wavelength it is the same. But here it bend a lot. Here it bend little. So I will just say when A is smaller than lambda or lambda is big, A is small. So the diffraction is obvious. Obvious. So what is diffraction again? Diffraction is bending of the wave, spreading of the wave when the wave go through a gap or an obstacle. Now, I want you to memorize one thing. When A is small, when the A means the A is small. Obvious, that's all. I mean diffraction obvious. Diffraction is obvious. When the A is big, it is not obvious. When A is big, not obvious. A is big, not obvious. A is small, obvious. A is small, obvious. A is big, not obvious. Right? I want you to memorize. When the A is small, then the diffraction, it is obvious. That's all. Question from here. Now I want to ask you, lambda more than A. Lambda bigger than A. Obvious or not obvious? Mean the A big or small? Mean the A is big or small? Mean the A is small, right? Mean the diffraction obvious or not? What do you think? A is small, mean lambda is obvious. Is that okay? A is small, lambda obvious. You don't memorize a lambda bigger than A bigger than lambda. You just memorize one thing. A small. I tell you, A big or small. If small, then obvious. So this thing you will bend this way. Right? Is that okay? So the direction change. I haven't drawn the direction of this one. I'm sorry. So you see the direction, it changed in this way. The direction changed in this way. The direction of propagation changed. I didn't draw the direction. Right? It went. Okay, one more time. A is like that. Obvious or not obvious? This one obvious, right? Obvious or not obvious? Not obvious. Right? A is big. A is big. That means lambda is small. Lambda is small. Mean lambda is small. A is big. So diffraction not obvious. Is that okay? Okay. Now here, you see, when I draw here, right? Here it is a gap, right? If you just stand behind me, right? Just not stand behind me, stand in front of me. I draw here, right? You feel the wind, yes, but very small, very small. Why? Because the wind come to here, the wind wave it go through the small gap here, it will spread, it will go away. So you don't really feel it. But once I make the slit, the gap bigger, right, you will feel, wow, the wind so strong, right? Because it's go focus to you, right? It will focus at you. Okay, if the opening big, it will focus. The opening is big, then it will focus. It will more concentrate here. But if the opening is small, then it will spread. So here it is not that strong. Okay, now I want you to notice here. Now the energy here, energy for here, it is lesser. I mean the amplitude will be lesser. Compared to this, energy here, it is more stronger, right? Amplitude here, it is bigger. Amplitude is big. Energy is big. Amplitude here is small. Energy is small.